This video will talk about how to determine what an ionic compound formula is if you know which elements are participating in the compound. To do well in this, you'll want to have a good grasp of what a valence electron is and how those are determined for a particular atom, and how protons and electrons add up to make ion charges. So, when you are looking for the charge on a particular element, what we want to recall is that every atom wants the same number of electrons as the nearest noble gas, which is fantastic. That means we can look at the periodic table and figure out how many electrons something would gain or lose to be like the nearest noble gas. It turns out that metals will generally lose electrons because that gets them to the noble gases more quickly, and nonmetals will generally gain electrons. When a metal loses an electron, it creates a positive ion. If you think about it, if you're starting with, let's say, some atom that has 12 electrons and 12 protons, if you take away 2 electrons, lose 2 electrons, then now you have 10 electrons left. You still have those 12 positive things, and so now your overall charge is a +2. So losing electrons creates cations, or positive ions. On the other hand, gaining electrons creates negative ions. That kind of makes more sense to us because you're adding negative particles. So if you start with something that's neutral and you add negative stuff, then the thing that you have left over should be negative. When you look at the periodic table, remember the noble gases are right over here. They are our last column on the periodic table. And we also remember that this number up here in a neutral atom is both the number of protons and the number of electrons. So that's technically the atomic number, but when it's neutral, then our protons equal electrons. So if I wanted to check out, say, fluorine, I see that fluorine starts with 9 electrons. Its nearest noble gas would be neon. How many electrons does neon have? Well, it's got 10. It's 1 more electron than fluorine. So fluorine will gain 1 electron to be like neon. When it does that, fluorine still has 9 protons, but now it has 10 electrons, which means it's got a negative charge. So we have fluorine with a -1. What's handy about the periodic table is all of the halogens, let's leave out astatine for now, fluorine through iodine, have a -1 charge. If we back up 1 to oxygen, we see oxygen has 8 electrons to begin with. It wants to be like the nearest noble gas, who is also neon. Sorry, helium's too far away. It wants to be like neon, and we see that oxygen would just gain 2 electrons and be a -2 charge. Let's check out, and so sulfur and selenium would also be -2s. If we follow our trend, then over here we should have -3, and over here we should have -4. Noble gases, they generally don't form ions because they're perfectly happy. Everybody wants to be like them. They have what's called generally a full octet, and so they don't really have any interest in losing or gaining electrons. If we look at lithium over here, it has 3 electrons. And you check out the noble gases, I'm going to do some erasing here because it's kind of messy. If you check out our noble gases, lithium has 2 choices. It could either go to helium, who has 2 electrons, or neon, which has 10. Well, for lithium to have the same number of electrons as neon, it would have to gain 7 electrons. Versus if it wanted to be like helium, it would just have to lose 1. And it's a lot easier to lose a smaller amount than it would be to gain 7 electrons. So lithium says, hey, I'll lose 1 electron, in which case then lithium still has 3 protons, but now it only has 2 electrons because, hey, it wanted to have the same number of electrons as helium, and helium only had 2. That means lithium now has a +1 charge because it has 1 more positive than negative. This is true of everybody in the alkaline metal column. So these guys all are +1 ions when they form ions, and the alkaline earth metals are all +2 cations. When we look at these guys here in the middle, these are the transition metals, And some of them have only one charge, but lots of them have multiple charges, and so we can't look at the periodic table and decide what their charge is going to be. These guys over here are called main group metals, or fixed charge metals, because they always have a +1 charge and a +2 charge. There are a few elements in the transition metals that stand out. In particular, silver is usually a +1, and aluminum is usually a +3. So, what ion is formed by each element shown below? And you'll want to grab a periodic table to have handy while you do this. Calcium, if you check your periodic table, is located in the alkaline earth metals. It's in the second column. So we know that calcium will always form a +2 ion. Phosphorus is a nonmetal. It's 3 boxes away from the nearest noble gas, so it forms a -3 ion. Lithium is in one of the alkaline metals. It's in the first column of the periodic table, and it will always lose 1 electron to form +1. We just talked about that. And iodine is a halogen. Fluorine, bromine, chlorine, iodine are all halogens, and they all form -1 ions because they are just 1 away from the nearest noble gas. So that brings us to, how do you figure out what an ionic compound formula is? Well, metals are always written first in the formula. Nonmetals are written last. And you already have some experience with this because you've probably heard of this compound, sodium chloride, table salt. Notice, sodium's a metal, it's written first. Chlorine's a nonmetal, it's written second. Use the lowest whole number ratio of ions. So if really what I needed was Na2Cl2, that's not the lowest whole number ratio of ions because I can divide both of those 2's out and rewrite it as NaCl. The amount of each element is written as a subscript. We knew that from our conversation about chemical formulas, but it's a good reminder that the fact that there's nothing written here or here tells me I have 1 sodium and 1 chlorine. If instead I had, say, sodium sulfide, then you can see I have 2 sodiums for every 1 sulfur. The total sum of the charges from the ions has to add to 0. So in sodium chloride, if you check your periodic table, you'll see that sodium has a +1 charge and chlorine has a -1 charge. 1 of each, whole thing adds to 0. Over here in my picture, I've got sulfur and some potassiums. If you check your periodic table, you'll see that potassium has a +1 charge and sulfur has a -2 charge. So when I combine those together into an ionic compound, I see that I need 2 potassiums to cancel out the -2 from the sulfur to make the whole thing add to 0. Since I have 2 potassiums in my algebra here, I have K2S as my formula.